evolution, in evolved systems, we can kind of think of evolution as defined by three primary characteristics, which is mutation occurs and then selection occurs, but selection is two things. Does the agent survive and does it reproduce? So survival, selection, mate selection. And then obviously that is survival and mating within evolutionary niches. Now, something to understand about that is that the mutation pressures that are affecting everything in an ecosystem, there's a kind of evenness of the distribution of mutation pressures. Whether we're talking about gamma rays or oxidation or just copying errors or viruses, they're affecting all of the lions pretty similarly, and the lions and the gazelles and the plants. So we don't have radical mutation occurring in one place and no mutation occurring somewhere else. And so as you have a mutation that would make a lion faster or any predator faster, you have similar mutations that have a distribution in the fastness and slowness of the prey animal. So then, of course, if you get a little bit faster in one and they say the lion eats the slower gazelles, then the fastest gazelles reproduce, and that leads to doubling down on those genes. So that's the next part, is not just a evenness in the distribution of mutation, but also co-selective pressures. And so the advances anywhere lead to a pretty strong symmetric coupling of power across the whole system. And so this leads to a situation where you do have rivalrous dynamics in nature. You do have something like individual agents doing self-maximization. Of course, it's not purely that. We have a lot of symbiosis. We have animals that are paying attention to their young and animals that wouldn't survive if not for the whole group of animals. But you can model individual self-optimizing agents and get a certain successfulness if you have this symmetry of power. So you have this lion and this gazelle are in rivalrous dynamic, but all lions and all gazelles are symbiotic with each other, meaning the lions would die without the gazelles would die without the lions. And as either one makes an advancement, it drives the other one to make an advancement. So this is kind of where, when we think of social Darwinism, we think of the idea that competition drives innovation and advancement and those types of things. The difference when tech comes about is, so again, these changes in the animals are happening mediated through genetics, mutation of the genes, and then survival, and then recombinatorics of the genes. So the genes are physically instantiated pattern replicators. When technology, I don't just mean physical tech, I also mean language. I also mean social tech, coordination tech, but so techne in the Sanskrit sense of consciously mediated methods of doing things, basically things that come from the capacity for abstraction and creating abstract pattern replicators. The abstract pattern replicators can change much faster than the instantiated ones can, and they can change with an uneven distribution. So when we think about tool making, starting with, Homo habilis and stone tools, right? Which is very different than a chimp using a rock that it finds, but not whittling sharper, or chipping a sharper rock, which is that the chimp or the bird or the whatever it is that's using something can experientially notice that this thing is better at doing what it wants than this thing is in the moment. But it can't understand that between all three rocks, why this one is better at cutting the thing is because of the abstract principle of sharpness, and then say, oh, I understand what mediates sharpness and I can design something with more sharpness. That abstraction capacity seems to be part of how we define early humans and then got doubled down in Homo sapiens. And it's a different process than evolution of bringing new stuff into existence. It's not occurring through kind of random mutation and just selective dynamics. It's occurring through an agent that's actually understanding something abstractly and intentionally creating it. And so if you think about evolution as the stuff that emerges, there wasn't a conscious choice to have something emerge. It emerged as the result of complexity dynamics. So it's unconscious, it's radically parallel, it's radically distributed, it's radically combinatoric, it's slow, almost everything fails, but you get a interoperability of everything. So what makes it through are very self-stabilizing complex systems. With technology, it's actually consciously created. It can happen in a local way, not everywhere. So it's not radically parallel and decentralized. It happens more in a serial fashion. And it creates parts that are not necessarily in equilibrium with whole systems. And so it really is mathematically almost an opposite kind of creative process. And the thing is, if you have an evolutionary agent, like a human that has evolutionary motives, but is now able to, say, human operating as apex predator can increase its predatory capacity orders of magnitude rapidly, faster than the environment can increase its resilience to that predatory capacity. Now we have a fundamental problem. This is a lion getting 1,000 times faster in a hurry without gazelles being able to make a mutation in adequate time, and the lions eat all the gazelles and then go extinct.